Hi guys, what is up? This is Radko Academy and my name is Professor Wada. And in this video, I just want to share with you how you can go about finding the gradient of a straight line where you have been given, as you can see, where you have been given the equation of that line, okay? And also how you can find the equation, the gradient, how you can find the equation of the line given the 2 points on the x or y plane. So if you're new to this channel, please make sure that you do subscribe to my channel for more information and for the latest content such as this one. So you can also find me on YouTube with Radko Academy, and also on Facebook as also Radko Academy. Okay, so without now much further ado, let's now dive into that. So when you look at this one, you're saying that find the gradients of the lines A 2x minus 3 and also B equals to 5 and B 2y plus x equals to negative 1. Now the most important thing to understand is we must be able to know the standard equation of the straight line. Okay, and we know from that concept that the standard of a straight line equation is y equals to mx plus c. Okay. Now this is the standard equation, or rather the general standard equation of a line, of a straight line. Okay. So now for us to find the gradients of these lines, all we have to do is by making sure that we map this equation, okay? We map this equation to the original equation, okay? And the way you do it is just by making y the subject of the formula, as simple as that, okay? Okay, so now what we're going to do is we have to find the gradients, okay? And we know from that perspective that the gradient we know that from that we can use this equation, which we call the standard general straight line equation. Okay. So from this one, we can now map the given one to this general standard equation. And this is how it is going to be. So we are going to make y the subject of the formula. Okay. And this is going to be 2x minus 3y equals 5. So the first thing that you're supposed to do is to make y the subject of the formula. Okay, and the way you do that, okay, we are just going to get everything. 2x goes to that side. Okay, so we're going to have negative 3y equals to 5 minus. So now when 2x gets to the other side, it becomes negative 2x. Okay, and then what you do from there, you divide negative 3, negative 3, negative 3. Okay, so from this point is this cancels, okay. Now we are going to have y equals to 5 over 3 minus, this is negative and negative cancels, so we are going to get plus just 2 over 3x. So now, once you do that, we are just going to rearrange now these terms, where we start with these terms which contains the x, as in this one, okay? So the coefficient of the x variable is normally the gradient that you're looking for. Okay, so therefore, y equals to, start with 2x, 2 over 3x, plus, so this one is positive, okay, plus 5, okay. Now you can see now clearly from the board that this one is now confirmed to the standard equation, where y is the subject. Okay, so you can see that y equals to mx plus c. Okay, so what this means that we are now we have made this given equation looks like the original standard general equation of a set line. And this simply means that y equals to y, we have that the coefficient of x, which is just m, is this one, and that is, by the way, the gradient. And this one, c, which stands for the constant, is the 5 there. Okay, so therefore, the gradient is equal to 2 over 3. So that is how you find the gradient of a straight line when you are given its original equation. So that's how you can go about finding that. So now, make sure that you do understand the first thing, the first fundamental principle that you have to understand is you have to map the original standard straight line equation to the given equation, where we make y the subjective formula, and then also kind of map each term from the given one to the original standard equation of the straight line, and then we can be able to identify that m, which is stand for the gradient, is in this case 2 over 3, and that's how you can just do that.